graphing f of x equals ax squared plus c. Just like in 8.1, we're now going to be graphing the same f of x equals ax squared but plus c. So when you see the plus c, you're going to shift up, okay? You're going to shift up. When you see minus c, you're going to shift down. When c is greater than 0, the graph f of x equals ax squared plus c is a vertical translation. C units up, okay? That means that it's positive. Here you could see it in the green. Blue is our parent, okay? It's our parent quadratic function. C greater than 0 means that you're going to shift up. When c is less than 0, our quadratic function is going to be now a vertical translation, units down, okay? Units down. In this case, you can see it here in the red. It goes down from comparing it with the parent function. Instead of your vertex being 0, 0 when it's f of x equals ax squared, now with the f of x equals ax squared plus c, you're going to have a vertex of 0 and c. And your line of symmetry, when it's 0, c, your axis of symmetry is going to be x equals 0. So here you can see we have a comparison. They want us to compare the graph to the parent, which in this case is f of x, x squared, correct? So it's the same thing as before. We're going to have 0, 0, negative 1 and 1, 1 and 1, 2 and 4, and negative 2 and 4. Let me try to graph this parabola. Now with step 1 done, okay, step 1 done, which is graphing the parent. For a comparison, we're now going to create a table with g of x equals x squared minus 2. I'm going to use the points x, g of x, going to use points negative 1, 0, and positive 1. Okay, so if I work this out, I know that in substitution, when g of equals negative 1, we're going to have negative 1 squared minus 2, which gives me, this becomes positive 1 minus 2 gives me negative 1. When we're looking for x to equal 0, we're going to have 0 squared minus 2. This becomes 0, and 0 minus 2 gives me negative 2. When x is 1, g of 1 will be 1 squared minus 2. I know this becomes 1, and 1 minus 2 gives me negative 1. I'm able to graph now g of x, which is negative 1 and 1, 0 and negative 2, and 1 and negative 1. So here, I do not have a vertical shrink or stretch, because here, I do not have a, correct? I don't have a, that's a 1. So it needs to be greater, not equal to, but greater. So here I have a vertical, put in blue, translation, 2 units down, correct? 2 units down. What else do I have here? A vertex of 0, negative 2, and an axis of symmetry of x equals 0. So I can see that the vertex from the parent that was 0, 0, it is below 2, right? So this is for f and this is for g. The vertex is 0 and negative 2. Here we have the same thing, but we're going to have plus 1. Plus 1, that means I'm going to shift units up, correct? And my A now it's 4. So that means, and that's greater than 1. I'm going to have a vertical stretch, okay? So that we know as much. So first, let's graph our parent for the comparison. Same, 1, 1, 0, 0, negative 1 and 1, 2 and 4, and negative 2 and 4. Oops, I did not go through the line. Okay, I'm going to now in step 2 create my table for my line of g of x equals 4x squared plus 1. I'm going to use negative 1, 0, and positive 1. If I use a substitution, I'm going to have, for negative 1, it's going to be 4 times negative 1 squared plus 1. I know that this becomes 1, so 4 times 1 is 4. Plus 1 gives me 5. I know that when it is to 0, I'm going to have 4 times 0 squared plus 1. This becomes 0 completely. So my answer is going to be 1. And when my x is 1, I'm going to have 4 times 1 squared plus 1. This becomes 1 times 4, which is 4 plus 1 gives me 5. I'm able to graph right away, which is negative 1 and 5, 0 and 1, and 1 and 5. So I could see that there is now going to be a vertical stretch. Okay, this is going to be a vertical stretch with what? A vertical stretch by a factor of 4. Okay, and I have a vertical translation 1 unit up. My vertex from my new vertex, well, not my new vertex, my vertex of G, okay, my vertex of G from the F, which was 0, 0, now is 0, 1. And both graphs have, okay, this is the vertex for g of x, correct? The vertex for f of x, we know is 0, 0. And both have a axis of symmetry of x equals 0. Here we have compare the graph again from the parent function, correct? So I'm going to graph right away my parent, which is still the same, okay? Now I know I'm not going to have, based on the function given, I am not going to have a what? I'm not going to have a vertical stretch or shrink because A is just 1, correct? So for those that understand it right away, you could just see that this this g of x equals x squared. It's the same of f of x equals x squared. The only difference now here is that we have a minus 5. And the minus 5 is telling me I'm going to shift 5 units. Let me write 5 nicely. 5 units down. Okay, so there's no need for me to work it all out. So I just could get from my original one of the parent, could go 5 units down. So it'd be 1, 2, 3, 4, 5. And any other points that I have, I'm going to go down 5 units also. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So I also could see that this is going to be, okay, this is going to be a little bit more. I have here a vertical translation of 5 units down. And I know between F, just remember this is F and G line, I know that the vertex of F is 0, 0, but of G is going to be, vertex of G of X is 0, negative 5. And they're both, okay, they're both with an axis of symmetry of X equals 0. Here I have the comparison again to the parent, and I have not gonna have a stretch or shrink because A is 1, correct? Or it's not greater. A is not greater than 1, or it has to be equal to. But I have a vertical what here? A vertical translation of 3 units up. So I'm able to first graph my parents, which is the same points, okay? The parents is going to be the same points I've been using. Okay, remember those points were given to me at the beginning, correct? Now I know that it's going to be 3 units up. So every point that you have, just count 3 units up. 1, 2, 3. 1, 2, 3. 1, 2, 3. So here, that's my answer. Vertical translation of 3 units up. That is 1. We know that comparing the vertex, the f of x vertex is 0, 0. But with G, no, this is actually h, I'm sorry. H of x, my vertex now is 0, 3. And the axis of symmetry for both of them are going to be x equals 0. In number 3, we also are comparing again the same parent, right? But here we know that A is greater than 1. So I'm going to have a vertical stretch, okay? I'm going to have a vertical stretch. Okay, and I'm also going to have a vertical translation of 5 units down. Okay. Now, I am going to graph my parent, okay? I'm going to graph my parent. This information right here, I just got it by analyzing my function of g of x, right? But my parent is going to be the same, correct, that I've been working. So please memorize this parabola of the parent, okay? So this is going to be notability. You're able to get your parabola, your U shape, much more neater, okay? Now I'm going to create a table, okay? I have here, I'm going to have x, g of x, and I'm going to use the same ones that I've been using, -1, 0, and 1. You are able to use more points. The more points you get, the more precise you're able to graph your shape or any linear functions. Any function, linear function, your vertical functions in this case. So we're going to have g of -1 equals 2 times -1 squared minus 5. I know that this gives me 1. 2 times 1 gives me 2 minus 5 gives me -3. If I have it with 0, g of 0 is going to be 2 times 0 squared minus 5. I know this cancels out, so 0 minus 5, my answer is -5. If I have g 1, it's going to be 2 times 1 squared minus 5. I know that this becomes 1, and 2 times 1 gives me 2, minus 5, I get again negative 3. I'm going to graph this. This is negative 1n, negative 3, negative 1, negative 3, 0 and negative 5, and 1n, negative 3. Looks like a V, but it's supposed to be a U. Okay, let me try it one more time. Okay, so I know that I have a vertical stretch, okay, by a factor of, okay, vertical stretch by a factor of 2, correct? I have a vertical translation of 5 units down. I know in comparison my vertex from my f of x equals x squared and my g of x, I know my vertex of f is going to be 0, 0. But my g of x is going to be 0, negative 5. Okay. What else do I see? My axis of symmetry for both of them is x equals 0. In number 4 here, I have again the same parent. Okay, so let's graph that. I have 0, 0, 1, 1, 2 and 4, negative 1 and 1, and negative 2 and 4. So this is my parent, correct? My parent that I'm comparing to. Now here I can see that I have here a shrink. Why am I going to have a shrink? I have a shrink because this is less than, right? It's less than. A is less than 0. And I also have a negative in front of there. So that means that my U shape is going downward, correct? So I'm going to add a vertical shrink by a factor of 1/4. And I'm also going to have a vertical what? Vertical translation of 4 units up, correct? So that has been given. Okay, I already graphed my parent. So now let me create my table. So I'm going to have x, and then I have h of x. Now this is a fraction, because it's a fraction, and that fraction is to the 4th. I'm going to use instead, you could use 4 or you can use 2. Anything that will give me, when I compute, it'll be easier for me to work out. So I'm going to do negative 2, 0, and 2. So if I have x for negative 2, I'm going to have negative 1/4 times negative 2 squared plus 4. I know that this becomes 4, correct? And 4 times negative 1/4, I'm going to get negative 1. Negative 1 plus 4 gives me 3. Now when h is to 0, not h of 0, which I'm using for x, I'm going to have negative 1/4 times 0 squared plus 4. I know that this is going to be completely 0. 0 plus 4 gives me 4. If I have now positive 2, I'm going to have negative 1/4, 2 squared plus 4. Here I have 4, and 4 times negative 1/4, I get negative 1. And negative 1 plus 4 gives me 3. I am now ready to graph. Remember, this is f of x equals x squared. Now I'm ready to graph h of x. So it's going to be negative 2 and 3. Right, 0 and 4. And I also have 2 and 3. And I know this is going to be downward, right? So they kind of are colliding, right? So I know that it's a vertical shrink. Okay, we already know it's a vertical shrink by a factor of 1/4. It's a reflection also in the x-axis, right? It's a reflection in the x-axis. What else can we see? It's a vertical translation 4 units up from the graph of f of x, right? This is g of x. No, this is h. See, h of x, correct? What else can we determine? That our vertex here for h of x is 0, 4. But my vertex for f of x is 0, 0, right? And they both have a axis of symmetry of x equals 0.